I want to demo a really useful construct, and we're going to use the technique that this construct uses and make our own. So we've got a very alarming stack here with a lambda function, and the only reason we have a lambda function is so we can make some alarms using some metrics. And then we make two alarms, one for the duration of the lambda function exceeding some kind of threshold, and one for the number of errors of the lambda function exceeding some kind of threshold. And then at the bottom we have new construct A, and that's just taking in a folder that we've got locally with a lambda function handler in. And let's go to construct A, and construct A creates a new singleton function. Then it initializes construct B, and construct B creates a new singleton function. And then it creates construct C, or initializes construct C, and then we get another singleton function. Now these singleton functions all have the same UUID. It's a constant value that we're passing in. And the beauty of the singleton function construct is that it only gets added to a stack once. And so we can take it out of C, we could put two of them in B, we could take it out of A but leave it in B and C. It doesn't matter. It doesn't matter where it gets initialized. As long as you've got the same UUID, you'll get the same function. And that means that everyone in all these contexts can share the same function. A common use case for that is custom resources. Obviously we looked at AWS custom resource in a previous lesson, but what if we needed a custom resource? Maybe we want to use the AWS v3 SDK, maybe we want to use an upsert style custom resource where we would create or update the resource, depending on if it exists or not. Or maybe we have to tweak some of the SDK client settings because we need it to support some kind of different setting, maybe a different retry behavior. So let's look at how we can do the same thing that the singleton function does in our own construct, our own code. So we're going to make an alarm tagger. Whoops. I'll tell you what, actually, let's make a tagged alarm. So the default CloudWatch alarm construct doesn't support having tags, and it doesn't support having tags because the underlying CloudFormation resource doesn't support tags. So we're going to make our own version of the alarm construct, but ours will support tags. Oops. So we're going to have the scope, a string, and then we're going to use the alarms properties with some customization. So let's have our class, which is going to be iTaggedAlarm props, and we're going to extend alarm props, and we're going to add a field for tags. What kind of value should we go for? Tell you what, let's go and have a look at the documentation for CloudWatch, and we'll see how it would like us to tag resources. So it would like us to use a list of or array of tag objects. Okay, we'll do that. So we'll have an array of objects with a key. I've got to check that value. Whoops. With a key and a value. Okay. Scope, ID, props. And let's have props to be the iTaggedAlarm props. And oops, let's pass that to the parent in a construct. All right, and then we're going to make a new alarm, attaching it to ourselves. We'll just call it alarm, and we're going to pass in the props here. We could remove the tags field from this object if we like, but I'm just going to leave it in there for brevity here. All right, we've got our alarm, and now we want to do some tagging, and we're going to make a custom lambda function to do this, to actually perform the tagging. But the code is a little bit out of scope of this this lesson here, so we're just going to put this into an alarm tagger folder. We'll make an index.ts, and we are going to export a function called handler. I'm not going to do anything for now, we're just going to leave that as empty. And then we want to be able to set up our lambda function, so we're going to use Node.js function, which is really, really handy. And I'm going to pop and find one of our previous examples of those, so we can look in our very alarming stack. We've got one we can use as a reference, including a bit of an IAM permission. And then I'm going to make a new method called ensure lambda. and we'll paste that in. And I need to correct the import here on path, and I think we'll be happy. Lovely, so let's change that over to being the alarm tagger lambda. We're going to stick with node 18 and ARM, but I'm going to increase the timeout duration in case we have to do some retrying. And I think we'll leave the other options for that intact, and then we need to allow tagging alarms, and we're going to allow the tagging and untagging. So let's look for our IAM actions and condition keys reference. Let's find CloudWatch, and let's find the actions for doing tagging. So here we are, tag resource and untag resource, and then the prefix is going to be CloudWatch. Okay, so we have CloudWatch, tag resource, CloudWatch, untag resource. Okay, now at the moment, if we call this .ensure lambda here, that would create a new lambda function every time we do this, every time we initialize our tagged alarm construct. And we don't want that, we want one lambda that we're going to share. So let's see how we can do that. We're going to start by looking for the lambda function already attached to our scope. The problem is, if we just looked where we are currently, we could be several levels deep of nesting, if you like, in various different constructs and bits and pieces, and we might not be able to find the lambda function. So what we're going to do is we're going to get the stack of our current scope. So we're going to say the stack is stack.of this, and that will take us right back to the top of the construct hierarchy to the stack level. And then once we've got that, we can look at the methods we've got on stack, and we can, so you can use node, and then we're going to find a child, or attempt to find a child. We can use whichever one. We'll do try find child. Then we're going to need some kind of unique identifier. So let's make a private static lambda UID, and we'll give that a random value. So I'm just going to pop to the UID generator, and we'll grab one v4 UID. Lovely. Pop that in there, and then we're going to try and find a child with that ID. And then we can say existing function is going to be that. And then we can say if existing function, we're going to return it. And we have to cast it back to a Node.js function. Otherwise, we are making a new lambda function, but we have to be careful. We have to select the right ID here. And we can't attach it to this because then it will get put somewhere in the construct hierarchy. We don't know where. We have to attach it directly to the stack at the top level. So let's do that. And I think we are about ready. So once we've done that, we've then created our lambda. So we can say that's our tagging lambda, and then we can use a new custom resource, which we will attach to the scope here because it's going to be relevant for this particular alarm. And let's see what our custom resource properties is. So we've got service token, which is the thing that's going to get called, in this case our lambda function, and then a set of properties, and you can set a custom type if you want. Lovely. So let's say this is going to be going to our lambda ARN. So that'll be our service token there. And then we're going to have some properties. And likely we will have to pass in the maybe alarm ARN or alarm ID. Let's see what the API wants for tag resource. It wants the ARN. So yeah, we would have the alarm ARN. Let's pop alarm into a variable as well. And then we'll call it alarm.alarm ARN. Like so, and then of course we've got to pass in the tags, which is then going to be our props.tags. So this custom resource will trigger our lambda function, and we are generating that lambda function in a way where it will only get made once. So we find the stack of the current scope, we go and look for that lambda function or that construct based on a fixed ID. If we have it, we return it. If we don't, we attach a new Node.js function directly to the stack with that known ID. So let's have a look at that in practice. Let's pop back over to our very alarming stack. And let's change out these alarms here for tagged alarms. And it's going to have a little complaint at me because I've not put any tags in. So we have key, hello, and we'll have a value of world. Whoops. And let's just replicate that across to the other alarm as well. And then let's do a synth and see what we get. Oops, I've chosen a name that's not unique. So let's go with alarm tags, something like that. There we go. Okay, and if we look at the template.yaml, we've got some infrastructure for the actual brush your teeth function itself. Then we've got our first alarm for the duration, our custom resource to tag that alarm, which is pointing to the lambda function, and then the IAM role for that, and a policy for that role, and then the function itself. And then we have the second CloudWatch alarm and the tagging resource here again, and those point to the same function. So it doesn't matter where we define them in the construct hierarchy, it doesn't matter how many times we define them, we'll always get the same resource. And you can use this same technique here for anything. It doesn't have to be Node.js functions, it doesn't have to be Lambda functions, but we're just showing it in this example so that you make sure something is created once and once only.